In this video, I would give a definition of systems thinking by two researchers called Arnold and Wade. And the relevant publication for this video is from their article published in 2015 in a conference proceeding called Computer Science. And the article is called A Definition of Systems Thinking, a Systems Approach. So Arnold and Wade, the two researchers, briefly discuss a list of systems thinking definitions by different systems thinking scholars in that article. It is important to note that these are discussed very briefly to fit within a conference proceeding paper. So it might not give you the complete picture or background to where these definitions came from. However, it will give you a starting point if you wanted to go and read the introduction of this article to dig deeper into systems thinking authors and how they define systems thinking briefly. And you can always read each if interested. Following this review that they did of systems thinking definitions, they came up with a definition of their own of systems thinking based on or using a systems approach, in that systems should consist of a goal or a purpose, elements, and third, interconnections, which was inspired by the famous systems thinking scholar Donella Meadows, who I did several videos about using her material and her book. So let's go through the definition by Arnold and Wade to give you a different idea about systems thinking. So you can have that in your arsenal if you wanted to have a look. So Arnold and Wade try to identify a goal and then elaborate on both the elements and the interconnections between these elements in their definition. They've defined systems thinking as a set of synergistic analytic skills used to improve the capability of identifying and understanding systems, predicting their behaviors, and devising modifications to them in order to produce desired effects. This is under page 675. Now let's explain what each of these words mean, because they are full-on, official, formal, and could be confusing words in their systems thinking definition. So I do have the article here, and the way that they looked at each of these words is that they looked at systems as groups or combinations of interrelated, interdependent, or interacting elements forming collective entities. They defined synergistic in their definition as characteristic of synergy, which is the interaction of elements in a way that, when combined, produce a total effect that is greater than the sum of the individual elements. They defined analytical skills as skills that provide the ability to visualize, articulate, and solve both complex and uncomplicated problems and concepts, and make decisions that are sensible and based on available information. Such skills include demonstration of the ability to apply logical thinking, to gathering and analyzing information, designing and testing solutions to problems, and forming plans. Identify in their systems thinking definition means to recognize as being a particular thing. Understand means to be thoroughly familiar with, apprehend clearly the character, nature, or subtleties of. Predict means to foretell as a deductible consequence. And devise modifications mean to contrive, plan, or elaborate changes or adjustments. Arnold and Wade then explained the elements in their systems thinking definition, and they explain these elements as 8 in total. First of all, let's go through each of these, and again, I'm using their article to explain what each of these mean, which I listed on this slide. So let's talk about each element. First of all, recognizing interconnections. This is, they consider, the base level of systems thinking. And this skill involves the ability, your ability or anybody, to identify key connections between parts of a system. And they said even highly educated adults without systems thinking training tend to lack this ability, which is, I also agree with that. The second part is, or the second element is identifying and understanding feedback. So some of the interconnections combine to form cause and effect feedback loops. Systems thinking requires identifying those feedback loops and understanding how they impact system behavior. The third element they talked about was listed on this slide is understanding systems structure. System structure consists of elements and interconnections between these elements. Systems thinking requires understanding the structure and how it facilitates system behavior. Recognizing interconnections and understanding feedback are keys to understanding the system structure. Okay. And then the fourth element that they talked about was differentiating types of stocks, flows, and variables. Stocks refer to any pool of a resource in a system. This could be physical, like the amount of paint in a bucket, or emotional, like the level of trust from one friend to another. Flows are the changes in these levels. Variables are the changeable parts of the system that affect stocks and flows, such as a flow rate or the maximum quantity of a stock. So the ability to differentiate these stocks, flows, and other variables and recognize how they operate is a critical systems thinking skill. The fifth element they talked about, listed on the slide, is identifying and understanding nonlinear relationships. So this element refers to stocks and flows of nonlinear nature. It is as simple as that. It is conceptually possible to group this element under differentiating types of, under the previous one, which is differentiating types of stocks, flows, and variables. However, Arnold and Wade said that the latter seems to imply a linear flow, the previous point, that is, or the previous element. To avoid confusion, nonlinear flows are separated out in this into this element in this case. The sixth element they talked about and explained was understanding dynamic behavior in systems thinking. So this ability to understand dynamic behavior, interconnections, the way that they combine into feedback loops, and the way these feedback loops influence and consist of stocks, flows, and variables creates dynamic behavior within a system. This behavior, they said, is difficult to grasp or understand without systems training. Emergent behavior, a term used to describe unanticipated system behavior, is one example of dynamic behavior. So differentiating types of stocks, flows, and variables, as well as identifying and understanding nonlinear relationships, are both keys or essential to understanding this dynamic behavior in systems thinking. The seventh element listed on the slide that they explained is reducing the ability to reduce complexity by modeling systems conceptually. This element is the ability to conceptually model different parts of a system and enters the realm of intuitive, simplifying or simplification through various methods, including reduction, transformation, abstraction, and homogenization. Research shows that perceptual wholes can reduce the conscious accessibility of their parts. This theoretically allows the interpretation of greater complexity as the mind holds less detail about each whole. This skill could also be viewed as the ability to look at a system in different ways that strip out excess and reduce complexity. And the eighth and final element they talked about that relates to and is essential to systems thinking is the ability to understand systems at different scales. This skill involves the ability to recognize different scales of systems and systems of systems. So hopefully that gave you an understanding and appreciation of a different definition of systems thinking that Wade and that is created by Wade and Arnold based on a systems approach, and including where I explained here their definition, and also the elements, the 8 elements that they listed, which are essential to systems thinking, to their definition. And by the way, there are interconnections between these elements that they talked about, but unfortunately they talked about it not in a text. They didn't explain it in the article, but they explained it in a diagram, which I can't copy paste here because of copyright issues could be if I copy pasted their diagram. But for your information, they also talked about the interconnections between these elements in a figure they called figure 3 under page 676.